Alright guys, we're going to be on page 36 in the notes today, so we're skipping over a section because of the snow day. So our learning targets today are I can identify the scale being used for a scale drawing, and I can calculate the scale factor for a drawing. So there's a difference between scale and scale factor, which we'll talk about first. So the scale factor is the ratio of the model dimensions to the actual dimensions measured in the same units. So they have to both be inches or both be feet or whatever. Once you have the same units, then it's just this ratio or fraction, model over actual. And what the scale factor tells you is how many times bigger or smaller the model is than the actual. So for example, a scale factor of 1/30th means that the model is 1/30th the size of the actual. The other way to think about that would be the actual thing is 30 times bigger than the model. Scale drawings are proportional to the actual drawing. We talked about that before, that if it wasn't proportional, if the sides weren't in proportion, then the shape wouldn't be exactly the same. All right, so we want to maintain that shape, so they are proportional. So the scale factor is just the unit rate. So it's whatever you multiply the actual dimensions by to get the model dimensions. So if you kind of picture that you have a table, and you have the actual over here, and the model, your unit rate is whatever you're multiplying by each time. So here the unit rate is whatever I multiply the actual dimensions by to get the dimensions of the model. The difference between scale and scale factor is that we said scale factor, it has to be measured in the same units, both inches, both feet. The scale of a drawing can be in different units. So for example, 1 inch to 15 feet. All right, that doesn't mean that the actual thing is 15 times bigger than the model because they're not measured in the same units. All right, so let's look at an example here. So it says Celeste drew an outline of a building for a diagram she was making, and then drew a second one mimicking her original drawing. Fill in the table using the graphs, then determine if her second drawing is a scale drawing of the first one. If so, find the scale factor. So we're going to say this first one is the original, and then this is the second one. Alright, so the first thing we need to do is fill in the table. So step 1 says find the height and length of each rectangle. So if I just count the boxes, this one is 9 for the height and 3 for the length or width, whatever you want to call it. And then this one, if we look at the height, that would be 18. And then our width here, or length, would be 6. Alright, so I filled that in. So now we want to say if this is a proportional relationship. So if you remember back to when we were looking at tables and how to tell if they're proportional, alright, here's my x, here's my y. We're going to do y divided by x for each point on the table and see if that ratio stays the same. So I'm going to do 18 divided by 9, and I'll do 6 divided by 3. And if I divide each of those, they're both going to come out to be 2. So I'm going to say yes, this is proportional, which means this is a scale drawing of this one. It's exactly the same shape, just a different size. And then it says to find the scale factor. So we said the scale factor is the unit rate. It's whatever I multiply by to get from the original to the scale drawing, to the second version. So here we said our unit rate was 2. Each of these is times 2. So our scale factor is 2, okay, meaning the dimensions on the new one are twice as long as the dimensions on the original one. What we're going to look at now is how to actually figure out the scale factor if your units are already the same. So it says sometimes instead of being asked to find an actual measurement or scale measurement, like what we've been doing, set up the proportion and find the missing dimension, you'll be asked to find the scale factor. So to say, well, how much bigger or smaller is this model than the actual? And to find the scale factor, we're going to do 3 things. First, check to make sure that the units are the same, because for scale factor, the units have to be matching. Second thing you're going to do is write the ratio of the model dimension to the actual dimension. So you're going to write a fraction, model over actual. And then last step, just simplify your fraction. We're going to use the calculator to do that. So the first example says the length of a room in an architectural drawing is 10 inches. Its actual length is 160 inches. What's the scale of the drawing? All right, so And that should actually say scale factor. What's the scale factor? So the first thing we do is check to make sure that the units are the same. So if I look, it says the drawing is in inches, the actual is also in inches. All right. So now we're going to write the ratio of the model over actual. In this case, the model is the drawing. So I'm going to do model over actual. And if I look, it says the drawing is 10 inches. So I'll put 10 inches on the top. The actual length is 160 inches. So I'll put that on the bottom. And then step 2 is just to simplify. So if you take your calculator and you type in a fraction, it will simplify it for you. So I'll do 10 ABC 160 equals, and that simplifies down to 1/16. All right, so then it says, well, what does that mean? So if my scale factor is 1/16, that means that the model is 1/16 the size of the actual. Okay. You can also think of it as the actual is 16 times bigger than the model. All right. Or you can think of it as you would multiply the actual dimensions by 1/16 to get the model dimensions. Because we said that scale factor is the unit rate. It's whatever you would multiply the actual by to get the model. So let's look at another example here. It says refer to the model boxcar shown below. So this is the model. The actual length of the boxcar is 609 inches. What is the scale factor of the model? So I got to make sure my units are the same. So it says the actual is in inches, and if I look at the model here, that's also inches. So step 1, write the ratio of the length of the model to the length of the actual. So my fraction is always model over actual. So if I look at the length, we're talking about length, so if I look at the length of the model, that's 7 inches. And then it says up here that the length of the actual is 609 inches. So our fraction is 7 over 609. So then second step is just to simplify. So again, you're just going to type it in, 7 ABC 609, and let the calculator simplify it. So the calculator says that is 1/87. All right, so those ones are scale factor. All right, our units are matching here, inches and inches, down here, inches and inches. So all we had to do is write the fraction and simplify it. All right, for these next examples, we're going to look at how to find the scale factor if the units are different. So we know that to write the scale factor, the units have to be the same. So if they're different, we're going to have an extra step here. So to find the scale factor, these are our steps. Check to make sure the units are the same. If they're not, you need to convert one of them so that they are the same. Then we're going to write that same ratio, model over actual, and simplify. So our first example here says the height of a building on a blueprint is 10 inches. Its actual height is 150 feet. What is the scale factor of the drawing? So again, first step, make sure your units match. I've got inches for our model, and I've got feet for the actual. So we're going to have to do a conversion here. So it tells us right here that 1 foot is 12 inches. So our first step is going to be to convert 150 feet into inches so that then we have both of the same units. All right, so I'm going to start with my scale and use that to do the conversion. So 1 foot is 12 inches. We have 150 feet, and we want to know how many inches. So I'm just lining up feet with feet, inches with inches. And I'm going to cross multiply. So 1 times x is 1x, or just x. And then I do 150 times 12, and that'll give you 1,800. So 150 feet is 1,800 inches. And you don't have to use the proportion. If you know another way, that's fine, as long as you show your work. So we just changed 150 feet into 1,800 inches. So now we're going to go ahead and write the fraction, model over actual. All right, so it says the blueprint is 10 inches. That's the model. The actual, we just switched to 1,800 inches. And then again, you just type this onto your calculator to simplify it. 10 1,800, and that simplifies to 1 over 180. All right, meaning that I would have to multiply the actual dimensions by 1 over 180 to get the dimensions on the blueprint. All right, so let's look at another example here. A scale model of an airplane has a wingspan of 8 inches. In real life, the same airplane has a wingspan of 32 feet. What is the scale factor of the model to real life? So again, my units are not matching here. I've got inches here, feet here. So my first step is going to be to convert 32 feet into inches. So again, I can set up a proportion. 1 foot is 12 inches, and then I'll line up feet with feet, inches with inches. We have 32 feet, and then I'll put an X for the inches. And then if I cross multiply, 1 times X is just X, or 1X. 32 times 12 is going to give you 384. So we just changed 32 feet into 384 inches. Now that my units match up, the ratio is model over actual. So it said the model is 8 inches. The actual is 384 inches. On my calculator, 8, ABC, 384. And that simplifies to 1/48. So our actual plane is 48 times bigger than the model. All right, and last question. A scale drawing of a spider is 5 centimeters long. The actual spider is 10 millimeters long. What is the scale factor of the drawing? All right, so we know scale factor is model over actual, but it has to be the same units. Here I've got centimeters, here I have millimeters. If we look at the conversion, it says 1 centimeter is 10 millimeters. So I can right away change 10 millimeters into 1 centimeter. All right, now we have matching units. We have centimeters. So the model, it says the scale drawing is 5 centimeters, so that would be our model. The actual, we just said, is 1 centimeter. All right, so you simplify that, that just comes out to 5. You can leave it as 5 over 1 if you want to, but that's saying that in this case the model is actually 5 times bigger than the actual.